Okay, these next examples are finding the horizontal asymptotes of the function. So for number 9, we have 8x over 2x squared plus 1. That's our rational function. So we look at the degrees, okay, or our exponents, 1 and 2. So we said if the numerator is less than the denominator, okay, which is choice 1, then the horizontal asymptote is going to be the x-axis or just the line y equals 0. Okay. On number 10, the degrees are the same. So if they're the same, we say that the line y equals, this says a sub n over b sub m. That's just your coefficients of those leading terms. The line 10 over 5, no, I'm sorry, 10 over 2, just getting ahead of myself, or y equals 5 is my horizontal asymptote. Okay, it's just that ratio there. And then the third choice is if n is greater than m, so I have a degree of 3 and a degree of 2, there is no horizontal asymptote for this graph. Okay. The third type of asymptote that we're going to talk about is the slant asymptote. And, you know, from its name, it's usually some type of slanted line. It says the graph of a rational function has a slant asymptote only if the degree of the numerator is 1 more than the degree of the denominator. You find the equation of the slant asymptote by dividing the polynomials. You can divide by long division or synthetic division, it does not matter. So this is my example. I only have a slant asymptote if my numerator is 1 degree more than my denominator. Okay, I've kind of sketched what this graph looks like. Not exact, but just a sketch. I have the curve here and the curve here. Okay, I know I have a vertical asymptote of x is equal to 1 if I were to set that to 0. So this is my vertical asymptote. And then I've kind of drawn in what my slant asymptote is this slanted line. To find it, I chose to do synthetic division. So I took the coefficients of the numerator, which was a 1, then a 0 for x, and then the constant of 1, and I divided by a positive 1. Okay, brought down the 1, multiply gives me 1, add gives me 1, multiply gives me 2. Remember, this is my remainder when I'm dividing. I'm only concerned with the quotient and not the remainder here. Okay, my slant asymptote will be the line y equals 1x, this 1 goes here, plus 1. Okay, so whatever the equation of this line is here, when you divide, that's going to be your slant asymptote. So how did I graph that? Since I know that's a straight line, well, my y-intercept is 1, so I'll put 0, 1. And then my slope is 1, so I can just go up 1 and over 1, put a new point, down 1 and over 1 to put a new point. And so that's how you would find your slant asymptote. Okay, so as you can see from this example, a graph can have both a vertical asymptote and a slant asymptote.